Okay, today we're looking at hyperbola, and this is conic hyperbola, it's not rectangular, so if we actually cut this time with two cones end to end like I've got shown there, and we cut through there like so, what we end up with is two U-shapes, something a bit like that, so I haven't done that properly. So a couple of U-shapes a bit like that, so that's what we refer to as conic hyperbola. And they look a bit different when we graph them than the usual hyperbolas that we may be interested in. In that they end up like this. We have the centre in this case, and I'm just going to look at where we've got the centre at the origin, so centre is in here. We have some directrix or directrices, and here's our directrices, these two here, they go like so. We have foci, so there's the focus there, and there's another one at the other side as well. Alright, so it's for the two different parts of it, of course. And the line itself, we have a vertex here, another vertex there, and we have a couple of asymptotes. And so there's our asymptotes going like this, and so our curve goes something like that in some way. Alright, so the coordinates of all of these things again the same, we draw a line to some point P on our hyperbola and then straight down, so it makes a right with our directrix. Then our eccentricity, which is the length of those, is greater than 1. Alright, what else do we need to know? Okay, our centre, we've already mentioned that. Our vertices. So for this one, our centre 0, 0. And our vertices are at plus or minus a 0. Our foci, there's two of them, and they are at plus or minus a e and 0. Directrices, directrices are x equals plus or minus a on e, and our asymptotes are y equals plus or minus b on a x. And of course this relationship between b and a and the eccentricity, and that's the relationship, because remember these things aren't random, they are a pattern. Maths is about patterns. Alright, so page 351 on your textbook if you want to have a look at all of that business comes into it. But the only thing that I haven't actually put down so far is our equation. So our equation ends up being x squared on a squared minus y squared on b squared equals 1. So it's very much like the ellipse formula. The difference is we've got this minus here instead of a plus. Alright, so it's all kind of a bit of a mess. It is summarised in the textbook on page 355 with some diagrams there. Now, of course, if we do a translation, so let's remove all of that. If we do a translation then, let's do a translation x, y, so now our centre's going to be there, so there's our directrices, like so. Got a couple of foci, got one there and one here. Couple of directrices, one here and one here. And a couple of vertexes there and there. And so that's what it looks like. Alright. What happens now with all the other things? Okay, so we've got centre at 0, 0. Not 0, 0, what am I talking about? At h and k. So we have that same sort of transformation, that same translations that we had with everything else. Okay. So we got vertices at plus or minus a plus h and k. We've got foci plus or minus ae, then the translation plus h and k. Directrices directrices were x equals plus or minus a on e plus h. Asymptotes y minus k equals plus or minus b on a x minus h. Eccentricity, of course, greater than 1. And the equation is x minus h squared over a squared minus y minus k squared over b squared equaling 1. And of course b squared equals a squared e squared minus 1. Alright, so same sort of translations that we've been looking at for all the other things. Alright, so we'll now have a look at an example. And so we're going to sketch x plus 1 squared over 16 minus y minus 2 squared over 9, and that equals 1. So what do we need to know? Alright, so the centre is at h and k, so that's minus 1 and 2. A equals 4, B equals 3. Got there. So we need to know eccentricity, b squared equals a squared e squared minus 1, because we need the eccentricity to find other bits and pieces. I should have had to put the vertices down, but I'll get to that in a minute. So 9 equals 16 e squared minus 1. When you rearrange all of that, you get 5 over 4. So my vertices are negative 5, 2 and 3, 2. So we take those translations into account. Our foci alright, they're AE plus H, so when we do that we end up at 4, 2 and negative 6, 2. There's that. Our directrices. Plus or minus AE plus H, so when we do that, you get 11 over 5, and x equals negative 21 over 5. And our asymptotes y minus k plus minus b on ax minus h, and when you do all of those, excuse me, you get the following, and you get a rearranging involved here as well. So essentially you end up with that. Alright, so if we then go to put all that stuff on a graph, righto, there we go. So we're putting our stuff on our graph. So our centre was at H and K, which was at minus 1 and 2. So that's where our centre will be here. So our asymptotes will go through them. Alright, and so our asymptotes, we go something like this, and this. So that one's 3x minus 4y plus 11 equals 0. And this one's 3x plus 4y minus 5 equals 0. So there's that. Our foci are at 4 and 2. So there's one there. And the other one was at minus 6 and 2. So there's that one there. Our directrices were 11 on 5, and 11 on 5 is 2 and a fifth. So down there like that. And minus 21 on 5, so that's minus 4 and a fifth. So there's that. I should have put my coordinates there, 4 and 2 and minus 6 and 2. Now what do we need? We need our vertexes, or our vertices, and they are at 3 and 2, so 3 and 2, and minus 5 and 2, and so we end up with something that looks very much like that. Alright, so there it is. So that's it, just take your time with it, think through it carefully, don't try and rush and find all those things. You also summarise the equations, everything's summarised page 355 in your textbook. Okay, so you're up to now the next problem set for that, which is number 4.